Hey guys, how's it going? Welcome to day 29. Today we're looking at a very important concept as well. We're looking at concavity and inflection points. So let's start with a little bit about concavity. The concavity of a graph of a function f, right? When we look at the graph, we can tell based on the shape whether it's concave up or concave down. So let me kind of explain to you how that works. Okay, when we see a curve like this, there are different types of concavity to this graph. And one way I like to think about it, again, this is an F graph. That's going to be very important later on. There's concave up and there's concave down. And it has to do with the shape of the curve. So concave up on an F graph looks like smiling. Well, a graph is concave up if its curve is such so that it looks like it's smiling. Another way is if it's a cup, it would hold water. Okay? If an F graph is concave down, then it looks like the opposite, like it's frowning. So when we take a look at this F graph, we can see part of this graph looks like a smile and part of this graph looks like a frown. On the left side here, right, this part of the graph right here, the shape of the graph looks like a smile. Okay? The right side of the graph looks more like a frown. So I would say that this graph is concave up over here. And I would say over here the graph is concave down. And the place where we change, right, there's a spot somewhere on this graph where this graph shifts from being a concave up graph to a concave down graph. The place where it changes is called an inflection point. Okay? So if you kind of follow my cursor here, all the way over here out to negative infinity, this graph appears to be smiling. Smiling, 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 smiling. And then right here it starts to change to frowning. Somewhere in here is our inflection point. And again, an inflection point is when our concavity switches. Now, we learned in our video yesterday about increasing and decreasing, right? F increasing, F decreasing. Well, if you notice in this concave up section, part of the concave up section, F is decreasing. Again, over here, F is decreasing but concave up. But right here, F is increasing in concave up. So this is separate from F increasing or decreasing. Concavity is not determined whether or not the function is increasing or decreasing. Just like the concave down section, F sometimes was increasing, sometimes was decreasing. Again, this point right here, the graph is definitely frowning there, but F is still increasing. Here F is frowning and F is decreasing. So they're determined very differently than increasing and decreasing, right? We can be concave up and increasing. We can be concave up and decreasing. We can be concave down and increasing and concave down and decreasing. So what is going to determine for us whether our graph is concave up or concave down? Well, it's actually going to be the second derivative. Okay? So the derivative of the derivative. If we take a look at this, let's see what's happening to our tangent lines. Right here, my tangent line is negative and pretty steep. But notice how each subsequent tangent line, they're still negative, but they're getting bigger. Right? They're getting closer to 0. And then I hit 0, and my tangent lines become positive, but they keep getting steeper and steeper. So what's happening is my f prime keeps getting bigger, right? Over here, maybe it was a slope of -1. Here, -3/4. Here, -1/2. Here, 0. Here, 1/2. Here, 3/4. Here, 1. So those f prime values keep getting bigger and bigger and bigger, which means f double prime must be positive. Okay? Similarly speaking, as I track my f prime, once I pass the inflection point, again, I have a positive slope, maybe +1 derivative right here. I'll use a different color. Here, my tangent line is still positive, but it's a little bit less steep. Maybe the slope is 3/4. Here, maybe the slope is 1/2. Here, the slope is 0. Here, the slope is negative. Here, it's even more negative. Here, it's even more negative. What's happening is my f primes, my tangent slopes here, keep getting more and more negative. Okay? And that's how we can determine concavity without looking at a graph. So here is the rule. Again, this part should be in your notes. It's going to be in the Quizlet eventually here. Very important. So f is concave up. F is concave up when our second derivative is positive. Okay? So I can get to the second derivative and figure out if my second derivative is positive or negative. That will tell me whether the shape of my original f graph will be smiling or frowning. Okay? The reverse then is also true. F is concave down when f double prime is negative, less than 0. Okay. So if you get questions about concavity, you need to get to the second derivative, and determining where that second derivative is positive or negative will tell you where your f graph is concave up or concave down. So concavity, I want you tying to the second derivative. The second derivative sign tells us the concavity of f. Okay? And the last piece of information is f has an inflection point when f double prime switches signs. So that inflection point there in the graph that I drew above, right? That inflection point is when we switch from concave up to concave down. So f double prime would have gone from positive numbers over here to negative numbers over here. Okay? So let's talk about how this works then in terms of solving an equation. So let's take a look at this function here. F of x is going to equal x cubed minus 5x squared plus 14x minus 3. The question is, on what intervals is f concave up? Well, when you see this question, you immediately have to know the definition that f is concave up when f double prime of x is positive. So what I need to do is I need to find f double prime of x, and I need to figure out where f double prime of x is positive. This is very similar to the work that we did yesterday with increasing, decreasing, but now we're working with the second derivative as opposed to the first derivative, okay, to determine concavity. So here's what we do. First off, let's find the first derivative. So my first derivative is 3x squared minus 10x plus 14. Again, but that doesn't help me because I need to figure out the second derivative. So I need to do one more derivative here. And now I have the second derivative. And again, I need to determine on what intervals that second derivative is positive. To figure out where the second derivative is positive, I have to first figure out where the second derivative is equal to 0. So I'm going to set this equal to 0 and solve. Okay. So 5/3 is when my second derivative equals 0. By the way, will that be an inflection point? Well, we don't know until we test it. So what I need to do here is I need to make a second derivative number line. This is why I want you to label your number lines, because we'll be making first derivative number lines, we'll be making second derivative number lines. In the past, we've made v of t number lines, we've made a of t number lines, right? We want to always, every time we make a number line, they're very important. We want to label them so we can use it properly. So let's make an f double prime number line. And I'm going to plot my 0 of 5/3. So I know that the second derivative equals 0 there at x equals 5/3. But what I need to do now is test numbers to the left of 5/3 and numbers to the right of 5/3. So since 5/3 is positive, 0 would be to the left. 0 is always the easiest number to check. Plugging in 0, right? I'm going to plug it into my f double prime of x. 6 times 0 is 0. 0 minus 10 is negative. So that means f double prime is negative from negative infinity to 5/3. Now I just need to test a number bigger than 5/3. So maybe 2 or 10. Let's do 10. It's even easier. Plugging in 10 for x, I get 6 times 10 is 60. 60 minus 10 is 50. That's a positive number. Because I wanted concave up, I have to report the positive region of the interval of f double prime of x. So my answer will be f is concave up on the interval from 5/3 to infinity. And my justification is because that's where f double prime is greater than 0. If I wanted to report where the f is concave down, my answer would be from negative infinity to 5/3, because that's where f double prime is negative. But what about this question? What are the x values of the inflection points of f? So I told you the definition, right? If you look back in your notes just a little bit, I told you the definition is f has an inflection point when f double prime switches signs. Well, we're going to switch signs at 0, but notice I didn't say f double prime of x equals 0. We have to actually switch signs for an inflection point to occur. So when we take a look at this, right, when we set f double prime of x equal to 0, we got 5/3, right? We can do the same number line test here. And yes, in fact, 5/3 is an inflection point because notice we switched from concave down to concave up, right? F double prime of x switched signs at 5/3. Okay? It is not just solving it, setting it equal to 0. You actually have to test to make sure f double prime switched signs. So what are the inflection points of f? Justify. My inflection point, x value is 5/3. My justification is because f double prime of x switched signs. Now, what you'll notice here is we're starting to accumulate quite a few definitions, okay? So studying these definitions is going to be more important than ever. Okay? Let me show you one last problem. Okay? You kind of get the gist of how we can find concave up intervals, we can find concave down intervals, and we can find inflection points. Right? We don't need to see another example of that. But let me give you one more problem here. Okay, so here's our problem. F of x equals 1/3 x cubed plus 5x squared plus 21x minus 5. My question here is on what intervals is f both increasing and concave down? Justify. Now, we've answered these two questions separately, but now we're going to look at these two together. Okay? It's a little bit more difficult to do that. But we just have to remember our definitions, and then we have to answer the question. And it's going to come down to working with two number lines. I'll show you what I mean. Okay, so let's break this thing down. F needs to be doing two things. F needs to be increasing and concave down. Okay, that's going to look like going up, but frowning. It's going to look something like that. But let's think back to our definitions. What has to be true for f to be increasing? Well, f is increasing when f prime of x is greater than 0. Okay? But what about the second part of the definition? Concave down. Concavity relates to the second derivative, which means our second derivative must be negative. Those are the two things that I need to consider. And I have to meet both of those in order to report it. Okay, and again, I'm looking for an interval. I'm not looking for an x value, I'm looking for an interval. So from this time to this time. Okay, let's start with increasing. So the first thing I'm going to do is set f prime of, I'm going to find f prime of x. That's going to be x squared plus 10x plus 21. There's f prime of x. And I want to figure out where f prime of x is positive. So the first thing I want to do is figure out when f prime of x equals 0. I'm going to use the RS method. What two numbers multiply to 21? but also add to 10. That would be 7 and 3. Excuse me. That gives me solutions of -3 and -7. Okay. So those are the places where f prime is 0, right? Those are my critical points. But now I want to make an f prime number line and do my test. So I need to plug in a number less than -7. So let's try -10. -10 plus 7 is negative. -10 plus 3 is negative. A negative times a negative is a positive. Now I'll choose a number between them, like -4. -4 plus 7 is positive. -4 plus 3 is still negative. A positive times a negative is a negative. And then I'll choose 0. 0 plus 7 is positive. 0 plus 3 is positive. And I can see that f is increasing on the interval from -infinity to -7, union -3 to infinity. That's when f prime is positive. But what I need to figure out next is, I can't report that as my answer because I haven't even considered concavity yet. So the other thing I have to do is figure out when f double prime of x is less than 0. Well, in order to do that, I need to find my second derivative. My second derivative here would be 2x plus 10. I need to figure out where this thing is negative. So I'm going to set it equal to 0 and solve. Now, what I'm going to want to do here is I want to line up my second derivative number line test. I want to line it up right underneath my first derivative number line test. And I want to scale them the same way. So when I plot -5, I want to scale it kind of the same way this one did. So -5 would be right in the middle here. So I'm going to make it right in the middle here. See how I line those two things up? It's going to help me determine this a little bit better. Okay, now I'm going to choose a number less than -5. I'll use -10. 2 times -10 is -20. -20 plus 10 is negative. So I've got a negative sign over here. And then I'm going to choose a number greater than -5, which I'll choose 0. 2 times 0 plus 10 is positive. So here's what I need to do. I need to report the region where f prime of x is both positive and f double prime of x is negative. So when I take a look at this, right, we can kind of look here and say, this is what we're looking for, a plus and a minus, okay? This region right here, we have minus for f prime, minus for f double prime. This region right here, we have minus for f prime, plus for f double prime. This region, we have plus and plus. So the only place where f prime is both positive and f double prime is negative would be this region over here. Okay? So that would be from the region of -infinity to -7. My justification, because that's where f prime is greater than 0 and f double prime is less than 0, right? This gave us the increasing. F is increasing. This gave me f is concave down. What if I had asked the reverse question? I want f to be decreasing and f to be concave up. Well, here's where F starts decreasing at -7, but F double prime is still negative in that part, right? I don't switch until -5. So my answer would be from -5 to -3, F is decreasing and concave up. Because after -3 and to the right, F then switches to increasing. Okay? So reading these things can be a little bit of a challenge, but if you line them up, it can help you a little bit. All right, that's it for today. No new video for Friday. We'll just continue to practice with this stuff on Friday. Talk to you guys later. 2 chains. Bye.